In this video, we'll talk about the different characteristics of quadratic functions and quadratic relations. So I'm going to start with a very basic one. Actually, let's start with the general form, the standard form of a quadratic function. Sorry, bear with me. Okay, so standard form is y equals ax squared plus bx plus c, and a cannot be 0. I'll show you what happens if a is 0. Right now we have a quadratic function here, and if we change a so that it equals 0, there we go. We get a straight line. It's no longer a quadratic. So a has to be some number. And you'll see what happens as I change a. Now let's change b. And let's change c. Okay, so that's what it looks like in standard form. Now let's look at it quickly in factored form. And we've switched these forms back and forth before. You either expand and simplify or you factor to get the different forms. So the general form, or the general equation, for a factored form quadratic equation looks like this. Y equals x minus r times x minus s. So right now r and s are both set at 1. Let's see what happens when we change them. So now r is at minus 2 right here, and s is at 1. What happens if I change s to something else? Let's put it at, say, 4. Okay, see what happened there? Okay, so I'm going to talk about the different features. I'm going to let you play around with those in a little while. So let's talk about the general features, or the characteristics of a quadratic relation. So here's the most basic one, y equals x squared. So we have a b value of 0, and a c value of 0, and an a value of 1. Y equals x squared. So this general shape that you see here is called a parabola. Okay, it's kind of a U shape. Up at the top here, these two lines keep going on and on forever. If we zoom out, no matter how far we go, they'll carry on forever and ever. But the line at the bottom, where it comes to this curved, not exactly a point, but a curved lowest point, this is called the minimum value. So as long as the parabola is opening up like this one does, where the two lines go on into infinity in the positive direction, the parabola will have a minimum value, which is right along here at the bottom of the parabola. So the minimum of this one is at 0, 0, or y equals 0, because on the y-axis it's a minimum. If you were to fold this parabola in half so that the left side and the right side overlapped, the middle point, think about folding a piece of paper in half, the point where you have the line down the middle, that axis of symmetry that makes it the same on the left and the right, the axis of symmetry in this case is just the y-axis. So that the equation of the y-axis is x is equal to 0. So let me show you that here. X equals 0. There's our axis of symmetry. The vertex is the coordinates, or the point where it's at its minimum in this case. It could also be a maximum, and we'll talk about that in a minute. So the vertex for this is the point that's highlighted here at 0, 0. So as I've mentioned quickly, because this parabola opens up, it has a minimum, which means the vertex is at its minimum. And the axis of symmetry always goes directly through the vertex. The other key features to talk about are the y-intercept, which in this case is y equals 0. It crosses the y-axis at its vertex in this parabola. And there are also x-intercepts. So these are called zeros, like Z-E-R-O-E-S, zeros, or they can also be called roots. So the zeros or the roots or the x-intercepts with a parabola, you can either have 0 of them, you can have 1 of them, or you can have 2 of them. If the parabola was up here and crossed the y-axis somewhere up here, it's not going to cross the x-axis at all, so there aren't going to be any roots. If it crossed down here somewhere, whoops, down here, so that it went up, let's show you what that looks like this. So now it's crossing the y-axis down here. Now there's 2 zeros, and they are currently highlighted. So the 2 zeros are at x equals 2 and x equals negative 2. If the parabola were to be above the above the x-axis, like this, it doesn't cross the x-axis anywhere. The entire parabola is above the x-axis, which means that there are no zeros. In our standard one that we had there, y equals x squared, there's only 1 0, because it only touches the x-axis at this one point. In this case, it touches at its vertex at 0, 0. Okay, so now let's change this a little bit. Instead of y equals x squared, what happens if we have y equals negative x squared? Did you see what happened there? It flipped all the way over. So instead of opening up, now it opens down. It's still a parabolic shape, it's still a parabola. Now it opens down. The axis of symmetry hasn't changed. It will still be at x equals 0. So there it is shown in green there. Whoops. The vertex hasn't changed. It's still at 0, 0. The y-intercept is still at 0. The x-intercept, again, there's only 1 at x equals 0. Most things haven't changed. All we did with this one was flip it upside down. So what happens if we change something else? Let's look at x squared minus 4. Okay, I'm going to highlight some important points here. We still have an axis of symmetry at x equals 0. That's our equation. Our vertex now has gone down. It is now at 0, negative 4 right here. That's our minimum value as well at y equals negative 4. And the parabola still opens up, so it has that minimum value. The y-intercept is the same point as the vertex and the same point as the minimum in this case, still at y equals negative 4. And our zeros are at x equals 2 and x equals negative 2. Let's change something else in this equation and see what happens. Y equals negative 2 minus 3. Now we're getting some slightly weirder numbers because of the equations I picked. Oops, that shouldn't be negative 2, that should be negative 2x. Okay, so you'll notice that now our vertex has shifted. It's no longer right along the axis of symmetry is no longer at x equals 0. So let's see what we can do with this slider to get it through. There we go, right in the middle. So our axis of symmetry is now at x equals 1. The parabola still opens up, so it still has a minimum value at y equals negative 4. The y-intercept has now changed. It's at 0, negative 3 right here. And now our x-intercepts, or our zeros, are at x equals negative 1 and x equals 3. What if we flip something else around? Let's go plus. Okay, so instead of negative 2x minus 3, we have x squared plus 2x minus 3. It's still opening up. We still have a minimum value, which is over here at negative 1, negative 4. So our minimum value, the vertex point, is negative 1, negative 4. Minimum values at y equals negative 4, which is part of the vertex. The other part of the vertex comes from our axis of symmetry, right here. Might be easier if I just type it in. There we go. So our axis of symmetry is at x equals negative 1. Our minimum value is at y equals -4, so that's the purple line. And where the axis of symmetry and the minimum value meet, that's our vertex at -1, -4. Okay, so what are we missing? The y-intercept is right here at 0, -3, and our x-intercepts are here and here at 1, 0, and -3, 0. And again, those are called the roots. I'm going to take the same equation and I'm going to flip it upside down. I'm going to make the a value negative. Now look what happened to the entire thing. We have to change our axis of symmetry over here. Let's just type, much easier. Okay, so this parabola opens down now. These two lines will continue on forever and ever in the negative direction. So this has a maximum value here. And we will have to change our maximum value, the purple line, so it meets right here. So where our axis of symmetry at x equals 1, the green line, matches our maximum value at y equals -2, there's our vertex at 1, -2. Our y-intercept is here at 0, -3, and because the entire parabola is below the x-axis, we have no zeros and no roots. Alright, let's change a couple numbers here and see what happens. So I made it much bigger. Let's see. So what can we say about this one? It still opens down, so it has a maximum value. Our maximum value is way up here at y equals 13. Our axis of symmetry needs to go through x equals 4. Our y-intercept, if I zoom in over here a little bit, our y-intercept is still at 0, -3. And our x-intercepts are at really awkward numbers, but they're right here and here. Okay? So you may have noticed what happens if I change this c value. Let's change it to 4, and then look at our y-intercept, 0, -4. Let's change this to +5. Now where's our y-intercept? 0, 5. Change it to 9. Y-intercept is at 0, 9. Hopefully you're seeing a pattern there. Now let's switch over to factored form again. Oops, bracket x minus r x minus s. Put some sliders on. Here we go. So here's our general form of a factored quadratic equation. Now let's see what happens as I move the x value a little lower. So let's put it at -4 and 1. Oops. Alright, let's look at this. Where's our key points here? Here, 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 and here. There's our vertex, -5, -6.25. So our axis of symmetry will be at x equals -1.5. I can add that on here. X equals, what did I say? -1.5. Our minimum value is at y equals -6.25. There's our vertex. Here's our y-intercept, 0, -4. And here's our x-intercepts at 1 and -4. So if r, the first bracket here, x minus r, if r is -4, notice where the x-intercept is? it's at -4. S is at 1, and the intercept's at 1. So what happens if we take our R and S and change those to those numbers? We had X equals -4 and X equals 1. What happened here? Oops, this should have been 1, positive 1. But notice what happened? Now our x-intercepts are at 4 and -1. Why do you think that is? Well, that's because our equation had x minus r. So if r was -4, that would mean x plus 4 is in our equation. And if x was positive 1, the equation had x minus s, so -1. Now we're back to that same quadratic function here, and there's our two intercepts. So the key things with this equation is to realize that if the equation has x plus 4 and x minus 1, the intercepts are -4 and positive 1. If the equation had something like y equals x plus 6 and x minus 2, well, let's look. X plus 6 should give us an x-intercept at -6, and there it is. And x minus 2 will give us an intercept at x equals 2. And again, with any of these, we can always figure out where the y-intercept is. It's at -12. The vertex is at -2, -16. So our axis of symmetry will be through x equals -2. And our minimum value is at y equals -16. And that is really all you need to know. I think I've covered all the key points there. Now you get to do some practice of this on your own.